Right, so we're going to look at making good measurements, measuring correctly. I'm not teaching you in these notes how to make measurements. I'm hoping you already know how to actually do the measuring, but I'm going to show you the parts to make an accurate measurement. So our DQ that we're going to be looking at, and you have space on your notes for writing this down, is what are the pieces necessary for making an accurate measurement. So we're looking in chemistry at not just making measurements, but we want accurate measurements. So pause if you need to finish writing this down. To make an accurate measurement, we're always going to use the lines, even if they don't have numbers on them. We're going to use the lines for all the digits the lines can tell us, and then we're going to estimate one more between the lines. So an accurate measurement in chemistry always is an estimate. It ends with an estimate between the lines, or if you will, a guess between the lines. So let's go through some examples so you can kind of see what I'm talking about. So I've got a ruler here. I call it the red ruler because it's red. All right. And the numbers go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So these go by twos. So I'm going to come up here and let's get a bright color. There we go. And there you go. You can see how awesome my handwriting is. They go by 2 centimeters. All right. So my red ruler here that I'm holding goes by 2 centimeters. And there, that worked a little better there. Okay. And I have an object to measure. And I went to the store to find some unsharpened pencils, and I found out like no one's selling pencils because they're all sold out because of back to school, I guess. So I got these since Halloween is so close by. I'll try to like show it to you. I've got a little skull on a stick. So that's what I have here. So I'm going to measure my skull on the stick. So I'm going to put at the 0. I'm going to measure. Now here's what I want you to see. The point lies between the 10 and the 12, and about halfway between the two. So I'm not going to call this is not actually my pencil. This is my skull on a stick. How long is my skull on the stick? Well, it's not 10, which is a line. It's not 12, which is a line. So I'm going to guess between the lines. In my guess, I think it's going to be 11. So 11 centimeters would be a guess. And it is exactly that. It's a guess because I don't know that, well, I do know it's not on the 10. I do know it's not on the 12. I'm really not sure it's on the 11. Now, let me point this out. What if you're like, well, I'm not sure it's on the 11. Maybe it's like a 10.9897246. Okay. Well, catch what I just said. I am guessing 11. If I'm guessing 11, what would be the point of guessing a whole bunch of numbers after it? Okay. You're just guessing after guessing after guessing after guessing. I mean, that's like just redundant. There's no point in that. If I'm guessing even that it's 11, there's no point in trying to put more numbers behind it. So that's how I would measure with the red ruler. And that is really just the best I could do with my red ruler because it goes by twos. Okay. So what if we move on and we go by the green ruler? So I'm going to put the red ruler down and now I have a green ruler. And the green ruler is a little bit different. You might even be able to see the difference here on the screen. But it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20. Okay. So it goes by ones. So that's something new going on with my green ruler. It's going by ones. Now I'm going to take the same item and I'm going to measure now. And when I measure now, I do again see that it is not on the 10 line. I'm trying to line it up so I can like flip it over and show you. I may be defeating myself here. Okay, it's not on the 10 line. 10 lines over here. It's actually not even on the 11 line. Oh, but I have an 11 line now. And I can tell very clearly it actually, the point is past the 11 line. Okay. So what am I going to do? It's past the 11 line, not past the 12 line. So I do know the 11, but remember what I said at the beginning, an accurate measurement estimates between the lines. So I'm going to estimate between 11 and 12. What is between 11 and 12? The 10th place here. And it was just a little bit after the 11 line. So I'm going to estimate to a 2. That's a guess on my part. Maybe it's a 3. Maybe it is a 2. So your guess is as good as my guess, but here's the point. I'm certain of the 11. I am guessing one digit behind that. So I was certain to the ones place, and it's the 10th place where I make my guess. And that makes this as accurate a measurement as I can get with my green ruler. And that's what we want. We want to know how accurate you and I can be with the equipment that we're using. Okay, accuracy depends on the equipment, and the green ruler is certainly better, as we just saw, than the red one. Okay, I want to add another ruler here. Okay, so we're going to go on, maybe, there we go, to an orange ruler. And the orange ruler has the lines of 1, 2, 3, 4, 5, 6, 7, all the way to 20, but it has a bunch of little lines in between. And that's what I need to look at. So I see like a line for 10 and a line for 11. So that's a change of 1. But to move from 10 to 11, I'm counting 10 lines to move to 11, or 10 spaces, however you want to count that. Okay. So in counting that, those spaces are 1, because I'm moving from 10 to 11, divided by 10. So they're 1/10. In other words, these little lines are 10ths place, a 0.1. So with these little lines, I know for certain the 0.1s. So when I take my object here and I put it at 0 and I make my measurement, it is definitely a little bit after 11. I am seeing 11.1, 11.2. It's slightly after 11.2. So catch what I'm saying. Because of more lines, I can say, oh, the lines are worth, yep, wrong button. My apologies. This is what I want. Okay. The lines are worth 0.1. Because of the lines, I know for a fact 11.2. This is not any guesswork on my part. I can see 11.2. My guesswork is actually a little bit past the 0.2. So now I'm going to guess to the 100th place, because that's 1 after what the little lines are. And I think it's just a little after. So I'm going to go 3. And now that is my guess. I'm not really sure of the 3. Maybe it was a 4. Maybe you're going to look the same stick on the same ruler and say it's a 5. But that's okay. We guessed here. We are certain of the other numbers. And that is how we make an accurate measurement. We make a guess between the lines. We record all the numbers for all the lines, and then we make one final digit guess from between the lines. That's the only time you're supposed to be guessing, is that final digit between the lines. Okay, so now that we have done that, I want to just kind of recap here. Of the 3 rulers, so I had the red, the green, and the orange, which one did you feel was most accurate? Yeah, the orange one, right? Okay. So what is it about the orange one that really made it more accurate than either the red or the green? Hope you're saying it's the fact that I have more lines. I like to keep it simple. A lot of people have said this other ways, that's great. But really, it comes down to there's a lot more lines on the orange one, so I can make a better measurement, okay, a more accurate measurement. So again, this told me for certain to the 10ths, and I could make a guess in the 100ths. And that was way better than the other rulers. Something else I want to ask. Does it seem with the numbers I wrote down? So my first number I wrote down was 11. The second number I wrote down was 11.2, I want to say. And the third number I wrote down was 11.23. Do you feel the more digits in total a number has, the better its accuracy is? I hope you say, yeah, that kind of feels about right, because it does. It feels about right. All right. So we're going to say, yeah, typically it feels like the more numbers, the more digits that count towards the accuracy a number has, the more accurate it's going to be. So I want to give you a vocabulary word for that. You have some blanks to fill in here, and that is significant digits. Now, if I were to ask you for synonyms for the word significant, I bet one of them would be important. Please hear me say, please hear me say, all digits are important. Don't lose any of them. Okay, but chemists have a weird definition for significant digits. Significant digits are the digits that count towards accuracy. All digits are important. Not all digits count towards accuracy. So that's why I bring up this vocabulary. So you know significant digits is about the accuracy. Okay. So how do we know? Okay. All normal numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are significant. Done. End of story. If it's a 1, 2, 3, 4, 5, 6, 7, 8, or 9, it's a significant digit. It counts towards accuracy. So what's that leave that may or may not count towards accuracy? That leaves the zeros. So sometimes zeros will count towards accuracy. Sometimes they won't. Let's do a little bit of practice. But before we do that, I want to say one more thing. I want to point out the whole reason we care about significant digits is that we know then the guessed number, the number that is iffy, is the one that is the farthest to the right. I'm trying to point to the right here on the screen. There we go. Farthest to the right. Okay. So when we look at a number, we can go, oh, that came from the device, that came from the device, that came from the device. Oh, last number on the right, that was guessed between the lines. And so now you know where someone else rounded and other people know where you rounded. And that's a powerful communication tool right there. Okay, so let's look at some examples. Here's 15.0. By the way, we're probably on the back side of the first page by now. So 15.0. Now I'm going to tell you something. I'm going to tell you which numbers are significant here because I don't expect you to quite know that yet. So we have normal numbers 1 and 5. They are significant. And just take my word for it for now. I'm just barely introducing this to you tonight. 0 in that number is significant. So now you know. Maybe like somehow mark that on your paper. Significant, significant, significant. Okay. Now, what did I say a moment ago? The number farthest to the right is where it was guessed, where it was estimated. Big fancy word for guess, right? Okay, so which of those 3 digits is the estimated number? I hope you said the 0. So you might want to like make note of that. So I know for certain from whatever the measuring device my friend who gave me this number used, my friend knows for certain the 1 and knows for certain the 5. Maybe it wasn't a 0 afterwards. Maybe it was a 1. Maybe it was a 2. I know where my friend guessed when he wrote down the number 15.0. All right. Let's do a little more practice with this idea because this is important as to knowing where people made their guess. So I have 6 different examples for you to go here. So look at 19. What would you say, either the 1 or the 9, which one is the number that was guessed at? Was the estimated number, okay? Well, again, our rule is you go farthest to the right. So farthest to the right, these are both significant digits, the 9 then. The 9 is the guess number. I'm certain of the 1, maybe that was 18 though, maybe it was 17. Okay, but now I know where it was guessed at. That's what's important. What about 1.47? If we apply our rule of farthest to the right, which of those digits was guessed? Yeah, the 7. So I'm certain it's a 1.4 something. It may be a 1.48, it may be a 1.46, it you know, that's where the guess, maybe it really is a 1.47. Your guess is as good as mine, but I know where the guess occurred. Let's look at 1.009. All of those are significant. So which one is the number that was estimated or guessed at? Hope you said the 9, farthest to the right. How about 704.10? Now take my word for it. Those are significant zeros. I don't expect you to know yet. Just take my word for it right now. So if those are significant zeros, the one farthest to the right is right here, the 0 on the end. Okay, try 23.5. Hope you already said it's the 5. Hopefully that easy. Look at this very last number. I wanted to put something that might maybe make you think for just a moment. 10.000. Now I'm going to tell you all those zeros are significant. So which one is the guessed number? Hope you said the 0, and by saying the 0, like this last 0 here. Yeah. So check out what we're actually saying. We're saying the person who made this measurement was so accurate. We know the 10. We know the 0 in the 10th place is accurate. We know the 0 in the 100th place is accurate. We know this person did such a great job with accuracy. It really is down to the thousands place before we're kind of like, maybe not. So that's some really good accuracy there. So again, going back to the idea that does it seem like the more significant digits a number has, the more accurate it is? Probably. All right, now I want to give you another example, a different example. 2,500. Okay, now you should know the 2 and the 5 are significant because I already discussed those are always significant. I'm going to tell you something. Those zeros are not. Now, I don't expect you to know why. Just expect you to know that those are not significant. Just take my word for it. So now I do the farthest to the right significant digit is where the guessing was, and where was it guessed? Where was it estimated? Hope you said the 5. What are we saying? We're not sure that's 500. Maybe it's 400. Maybe it's 600. Maybe it is 500, but we really don't know for certain. We know 2,000 for certain. So is this a very accurate number? No, we feel like, no, that this is lacking, right? Okay. So let's do some more trying here. These should be kind of similar. A few of these I wrote in a way that just to kind of make you think just a moment. Don't overthink them. So here I have 6 examples. 2,200. Now the 2's are significant. If you didn't catch on already, those zeros are not. So which one did you circle? Which one is the guessed number, the one that was estimated? The second 2. I'm not sure it was 200. 2,000 I'm sure of, but not the 200 so much. How about 140? Okay, did you say the 4? Yeah, that 0 is not significant. If you didn't know, it's okay. Now you know. So the 4 is guessed. Could have been 130. Could have been 150. Maybe it is 140. I really don't know. That's where the guessing occurred. But it's good to know how accurate or not accurate the numbers that people tell me are. Okay, so 2030. Now I'm going to tell you something I didn't expect you to know beforehand. But when we have zeros between numbers, they get sandwiched. Okay, so this 0 is sandwiched between a 2 and a 3. That does make it significant. However, this 0 on the end is not sandwiched. It is not significant. So significant, 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 and not. So where's the last significant digit? The 3. Where did the rounding occur? Where was it estimated? The 3. I don't know if that's 30, maybe it's 20, maybe it's 40. Now that's not too awful. I'm certain of the 2,000, and 30 to 40 is not too far off with 2,000, but still, that's as great as the accuracy could be. Let's talk about the next number, 700. Those zeros are not significant. So where did the rounding occur? The guess or the rounding was the 7 in the 700. So we're not even sure this is 700. So let's say you decide to make a deal with me. You're going to mow my lawn all year long, and I'm at the end of the year after you mowed all year long, I'm going to pay you $700. but I use this kind of 700. So since I'm guessing at the 7, maybe when it comes time in December for me to pay you, maybe I'm like, oh, I guessed wrong the first time. Here's 500. You gonna be good with that? So that number is not accurate very well, is it? And you don't want to certainly have such an inaccurate number when you're making a deal with someone that involves money. That's why usually with money, we even go down to like the cents, okay, just to be sure that everyone understands the accuracy going on. But that's what I want to point out. Very, very limited accuracy there. But I got to know that, and now I do. I know that number is not all that great. 600,400. These zeros are sandwiched. If you didn't know that, that's okay. Now you do. These zeros are not. They're not significant. So where did the rounding occur? Where did the person guess? The 4. Yeah. And then tell me about 10. That 0 is not significant. So it's just the 1. So I'm really not even sure that is 10. That's as great a number as it is. So accuracy depends on using good equipment and making a final guess in between the lines. And if I don't have good equipment, I end up with numbers that don't have a lot of accuracy, which is why it's important to both have good equipment and to use it well. Okay, we're going to keep going because in the next half of today's lesson, we're going to go into lab and we're going to take some measurements. And I want to show you how to make measurements with liquids. So liquids, and I don't know if you can even see the liquid in my glass here, big old glass, but there is a little edge where the liquid line is at the top here. Okay. Pardon me there. Okay, so that little edge where the water or any liquid dips down inside the container, that's called the meniscus. Okay, and you know about a meniscus in your knee. This is a very different kind of meniscus. I think they're shaped the same, which is why they're both named the same. But this is called the meniscus. We're going to read to the bottom of the meniscus. But when we read to the bottom, we want to get our eye on level with the meniscus. So in lab, I expect you to like lift your head up or lower your head down to get your eye on level with the bottom of the meniscus to make a good measurement. So now that I know I'm measuring to the bottom of the meniscus, does it change how I measure with liquids? Well, no, not really. Now that I know that's what I measure to, I just measure. So check out what I got. I got a 30 mark. I got a 40 mark. If I count the lines, it takes me 10 lines to go from 30 to 40. Do count the like 40 mark where you end. Okay, so 10 lines or 10 spaces, however you want to count that out going on. Okay, that means 30 to 40 is 10, and I have 10 lines. So each line is worth 1. So I can go 31, 32, 33, 34, 35, 36. It's a little above 36, but it's below 37. So I know 36 with certainty. It's a little bit above that, and it's not 37 yet. So what's an accurate measurement? We measure the lines, 36. Now we're going to measure between the lines, 36 point something. And I'm going to look that I think that's a 6. That's kind of what I feel. Okay, and this would be milliliters. So 36.6 milliliters. There we go. So we actually like measured the same way. We use the little lines and then estimate or guess between the lines. With liquids, though, remember, you're measuring to the bottom of the meniscus. That's the only catch. Here's another one. No, okay, oh, come on. There it goes. Here's another picture. You have this on your notes already. But I want to discuss this because here's the weird thing. It doesn't go by ones. I go from 6 to 8. And there's 10 spots in between there. So I go up by 2 milliliters and there's 10 spots. So 2 divided by 10, it's going up by 0.2s. So 6.2, 6.4, 6.6. It's not at 6.8 yet. It's so I know kind of the 6.6. I don't know. Is that up at 6.7? It's not at the 6.8. It's not at, like, do you see the trouble I'm having here? Because the equipment is so low on accuracy, this is quite troubling. It is somewhere between 6.6 and 6.8, and there's a lot of numbers between there. I'm gonna say I don't quite think it's a 6.7 yet, so I'm gonna call that like a 6.67 or something like that. That's where I would make my guess. So I just want to show you where the lines could be different than a ones or a tenths. It can happen. Use the equipment well. And then check out this one other picture for you going on here. I picked this one for a reason. What do you notice about this picture? Hope you notice the numbers are getting bigger going down. And that happens. So these first two, usually with the numbers going up, that means they measure how much you're pouring in. When the numbers get bigger going down, you're actually measuring how much you pour out. So this is probably a burette, and it's a burette is a long tube where the liquid drips out the bottom, and you can go drip, 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 nice and slow. Be very accurate with your little tiny drops, okay? But that's why the numbers are going down. Now, once I recognize the numbers are going down, I measure it the same. I just have to be okay with the numbers going down. So check it out. My line is past the 7, but not at the 8. So I do know it's 7 something. Let's look at the little lines. I'm going from 7 to 8, and there's 10 lines to get me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th line lands on the 8. So 1 divided by 10 is 1/10. So it's going to go by 0.1s. So 0.1, 0.2, 0.3, 0.4, 0.5. It's a little below 0.5, not yet at 0.6. So I do know the 0.5. And now I'm going to make my guess here. So 7 I kind of feel that's halfway in between. I'm going to throw another 5 in there. 7.55 milliliters there. Okay. So I just wanted, like, the actual act is no different than using a ruler or something, except you need to know to measure to the bottom of the meniscus. So now you know. And you got to watch out for the numbers, because the lines could be different and the numbers might get bigger going down instead of up. And you just need to take care of that if that's the case. Okay, so wanted to take a moment to show that because you're about to do an activity where we're going to be measuring liquids. So now you know how to handle measuring liquids. Okay. Now let's pause and regroup and review. Our DQ was, what are the necessary pieces to make an accurate measurement? You're not writing this down again. You already wrote it down once at the beginning of the note, so we don't need to write it down again. But now we can answer. One of the pieces that's to making accurate measurements is having the correct significant digits by using the equipment correctly. So, and I think the word significant digits were supposed to be underlined there. So take a moment, pause the video if you need to, and like fill in the blanks. Okay. Now I'm going to just tell you right away the second piece. And a lot of you probably already would be doing this, even if I didn't mention that. So we need the right significant digits. That's going to be an accurate measurement. And we need a label. A measurement will always have a label. Way back when I started with these rulers, I mentioned centimeters. How did I know these were centimeters? Because it literally said right here, cm. So like I promise you, all the equipment we're going to use in lab, it's got somewhere on the equipment, it's going to tell you what it measures in. Centimeters, liters, milliliters, things like that. Okay. So let the equipment tell you grams. We have scales that electronic valences that do grams. So you need the correct amount of significant digits by using all the lines and estimating between the lines, making a guess there between the lines, and you need a label. Okay, so let's talk about, I already answered this. The colored ruler said centimeters, so we're gonna move on. Let's talk about combining labels, because sometimes the labels we measure with then combine together into like an overall label. Okay. So let's talk about combining labels. And I know, I'm sorry, we have to do a little bit of math review. And it's probably all rusty because you've had summer break and all that. So tell me, can I add 4x plus 3x? I hope you're saying yes. If I add 4x plus 3x, I'm going to get 7x. So I add the numbers and notice the x and the x stays in x. Okay, so what about in chemistry? So I'm going to talk not about x's, but I'm going to talk about, in this case, centimeters. Can I add 4 centimeters and 3 centimeters? I hope you say yes. I add the numbers, and centimeters stays centimeters when I add or subtract them. Okay, so the same would be true with subtraction. Okay. Now, can I add 4x and 3y? Hope you're saying no, I can't. That's the answer there. No, can't do it. Your math teacher can't ask you to do it. So if your math teacher can't ask you to add 4x plus 3y, can I ask you in a chemistry classroom to add 4 centimeters and 3 kilometers? No, I can't. Now, a lot of you are probably already jumping to the thought, well, wait a minute. What if I turn kilometers into centimeters? Okay, that's not what we're talking about. You're absolutely right, but that's not what we're talking about. I'm like, can I just add what I see right here? 3 centimeters and 4 centimeters and 3 kilometers. No, I can't. Okay, trick question, can't be done in chemistry. Okay. What about 5x times 2x? I hope you say, yeah, we can do that. How do we do that? Well, we're going to multiply the numbers, 10x, but then I accidentally said x, 10, but then the x's also multiply. So x times x is x squared. Pardon me a moment. Okay, what about 5 meters times 2 meters? Well, sure. 5 times 2 is 10, but what do we get with meters times meters? Meters squared. Yeah, a square meters. Same thing there, okay? So that's how we can take measurements. That's like me measuring this and then combining the two together with multiplication. I can do that. Here's how it would work out. Okay. What about this? Think about this for just a moment. This is very interesting. Can I multiply? I'm not saying add or subtract. Can I multiply 7x and 4y? I hope you're saying yes, I actually can. It's going to make 7 times 4 is 28, and I go 28 times x times y. 28xy. Okay, so if you're a little rusty, you're like, hey, yeah, I remember that now. Right, okay. So check this out. If I can multiply 7x and 4y, can I multiply 7 liters and 4 grams? Well, sure, I could. I really could. I'd get 28 liter grams. Now, I don't know what practically we would do with the liter grams. There's no like practicality to that, but that's not the point. I just wanted to review, could it be done? Yes, it definitely could be done. Okay, so now you know. Okay. All right. And so I want to leave and finish off the notes with some combining labels bits as review. Okay. So can I multiply centimeters and centimeters? Well, sure, I can. So let's do that. First, I'm going to multiply the 4 and the 6. So that's 24. And then I multiply the centimeters, and that's centimeters squared. Okay. Apparently, I've talked too much today. What about adding centimeters to centimeters to centimeters? Can I do that? So with adding, they all have to be the same. Oh, but look, they are. They're centimeters and centimeters and centimeters. So let's add them. 11 plus 3 is 14, plus 7 is 21, and centimeters with centimeters stays centimeters. Okay. Can I add 10 grams and 5 liters? No, that's a trick question. Can't answer that. Don't do it. Okay. Can I subtract 5.2 liters and 2.2 liters? Well, for adding subtracting, they need a match, but they do match. They're liters. So 5.2 minus 2.2, correct me if I'm wrong here, but I think it's 3. 3 liters. Notice the label just stays the same. Okay. So in adding, subtracting, the labels need to match and it stays the same. Can I do this? Meters minus grams. No, because they're not. For adding, subtracting, the labels need to be the same. And then the labels stay the same if I can do it. And can't do it. Don't do it. Okay. What about multiplication? Can I multiply meters with meters with meters? Well, they're all the same, so let's do it. 2 times 3 is 6, times another 2 is 12. Oh, but be careful. This is now multiplication. What do I get when I multiply meters times meters times meters? Hope you just said cubic meters or meters cubed. Yeah. Okay. Now, these last two, I want to show you an interesting way to think about this. You might find this very helpful as we go to practice in lab room. Okay. 8 grams divided by 4 milliliters. Let me write it this way. 8 grams divided by 4 milliliters. And the reason I showed that is now you can probably more clearly see the math work that needs to be done. 8 divided by 4 is, 2. And grams divided by milliliters is grams divided by milliliters, or we would say grams per milliliter. And this is actually a unit we use pretty often, grams per milliliter. So it's a great way to combine labels there. I'm combining a grams label with a milliliters label into one thing. And grams per milliliter is great. Let's try the last one. Again, let me suggest we write it this way. So multiplication is numerators and division's denominators. So write it out that way, like a fraction with your numerators and your denominators. So now that I've written this way, maybe you can see the math easier. 9 divided by 3, 3. Grams divided by cubic centimeters, grams divided by cubic centimeters, grams per cubic centimeter, which is also, again, something pretty often used. Okay, that covers our notes. I hope that gives a good foundation for the practice we're about to go do in the lab room. So you want to be sure you keep these notes safe. They'd be great things to start reviewing with before a test over all this, which is coming probably in about a week. And I'll see you next time.